Okay, so today we will be discussing about conservation of mechanical energy. Last day we have just started that. What is mechanical energy? It is the sum of kinetic energy and potential energy. When will a body have kinetic energy? When a body moves. What is the expression for kinetic energy? Half m v square. That is the expression for kinetic energy. Then this is gravitational potential energy. V. Potential is also denoted with the letter V. So potential energy is here represented with the letter V. Potential energy. So potential gravity. We are discussing about the gravitational potential energy. We have already derived expression for it. mgh. Gravitational potential energy is equal to mgh. Okay. Then total energy means what? Sum of kinetic energy and potential energy. That is mechanical energy. So here we are discussing a case of a freely falling body. A body is kept held at A. Held not moving. It is not moving. Body is held at A. And it is at a height h from the ground level. Body is at a height h from the ground level. Then what will be the potential energy of the body? What will be the potential energy of the body? mgh. mgh will be the potential energy of the body. mgh. Okay. Then what is the kinetic energy of the body? What will be the kinetic energy? It is at rest. Body is at rest. So for a body at rest, will it have kinetic energy? No. No.
Kinetic energy will be
zero. Yes. Kinetic energy will be zero. So that is what we have done here. At A, kinetic energy is zero because body is held at A, not moving. So kinetic energy is zero. Potential energy, it is at a height h from the ground level. So it will have potential energy mgh. Then we are adding both the energy to get the total energy. It is also known as total energy is also known as mechanical energy. So mechanical energy is equal to kinetic energy plus potential energy equal to 0 plus mgh. What is 0 plus mgh? mgh itself. So at A, we got the total energy as mgh. Okay, only potential energy is there at the highest point. Then at C we can see, at C, what is the total energy at C? Let the body be allowed to fall freely under gravity when it strikes the ground at C with a velocity v. So just before it hit the ground, that is the point C. C means lowermost point. Just before it hit the ground, what is its velocity? For that you can use this formula. V square equal to U square, V square minus U square equal to 2AS. And initial body is dropped. So initial velocity is 0. Therefore, v square minus 0 equal to 2. Here, what is acceleration? It is acceleration due to gravity. So, you can write g. Everybody is late coming. So, v square equal to 2 into g into h. Just before it hit the ground, by that time it traveled a distance h. It traveled a distance h from the topmost level. So h you have to give here. So v square equal to 2gh. Do you know why u is taken 0? Body initially held at A and then it is allowed to fall freely under gravity. So u equal to 0. So v square minus 0 equal to 2gh. Or what is the final velocity square? V square equal to 2gh. That v square we give in the kinetic energy expression. Kinetic energy equal to half mv square. Just before it hit the ground, what is the velocity? Square of velocity is 2gh. So that we substituted here half into m into v square is 2gh. 2 and 2 get cancelled, we get mgh. So kinetic energy of the body just before it hit the ground is mgh. So kinetic energy we got as mgh just before it hit the ground. Then what is potential energy? Just before it hit the ground means almost at the ground level. No h is there, no height is there. So mg into 0. You have to write mg into 0. So mg 0 is 0. Potential energy is 0, but kinetic energy is mgh. So what is the total of both these energies? Kinetic energy plus potential energy equal to mgh plus 0, that's equal to mgh. So we found at a topmost point, when it is held at A, its total energy is mgh, and when it is allowed to fall freely under gravity just before it hit the ground, then also the total energy is found to be mgh. One more position we are taking in between the free fall. I will show you that position once again. See this position. B also we are considering. So A, mgh is the total energy. C also mgh is the total energy. And at B also we can prove it is mgh. Total energy is mgh. How will you prove? Both the energies you have to calculate at this point. At the point B, what is potential energy? I will ask question now. What is potential energy when the body is at C? What is potential energy? At what height it is? All of you look the figure and tell at what height the body is from the ground level. H minus x height. Total height h, and from the topmost level A to B below, that distance is x. Remaining this height is h minus x. So total height from the ground level to A, it is h. And it is allowed to fall freely under gravity, and it moved a distance x and reached the point B. And what is its velocity at B? That you have to calculate, and you have to find kinetic energy. And at what height it is from the ground level, then you can calculate mgh. Apply that formula mgh. As in the place of h, what you have to give? Yes, I'll ask that question too. Yes, Lakshmi Priya, tell. Lakshmi Priya. Are you there? At a height, now when the body is at B, it is at a height h minus x from the ground level. What is the potential energy? Formula?
mg x minus h.
Correct. Mg into bracket h minus x. So mgh minus mgh. Correct answer. Very good. Then next, how will you calculate kinetic energy of the body at B? That I will ask to Aisha. Aisha, tell. How will you calculate kinetic energy of the body when it is at B? It already traveled the distance x downwards. How will you calculate kinetic energy? V square, final velocity, how will you find? Aisha is there. No answer. Akshaya. Akshaya.
Yes, ma'am.
Who is it? Akshaya?
Yes, ma'am.
Okay. Akshaya, tell. How will you calculate the velocity of the body, final velocity of the body when it is at B? Initially, it is 0. Body is dropped. So, initial velocity is 0. Final velocity V, how will you calculate? Which formula will you use to calculate final velocity? Just now I showed you when it is falling to a height h, which formula we used. Distance അറിയാം, acceleration due to gravity അറിയാം, initial velocity അറിയാം. അങ്ങനെയാണെങ്കിൽ final velocity എങ്ങനെ കാണും? ഏത് ഫോർമുലയാണ് ഉപയോഗിക്കുക? പറഞ്ഞു.
ut plus.
അവിടെ t തന്നിട്ടില്ലല്ലോ, അപ്പൊ പിന്നെ ഏത് ഫോർമുല ഉപയോഗിക്കും? ഞാൻ പറഞ്ഞില്ലേ യു ഉണ്ട്, യു ഈക്വൽ ടു 0 ആണ്. പിന്നെ നമുക്കുള്ളത് ആ വി സ്ക്വയർ മൈനസ് യു സ്ക്വയർ ഈക്വൽ ടു
2G.
2GH. എക്സ് ഇവിടെ എക്സ് ആണ് ഹൈറ്റ് കേട്ടാ. എക്സ് ഡിസ്റ്റൻസ് അല്ലേ താഴത്തേക്ക് വന്നിട്ടുള്ളത്. അപ്പം എസ് ഡിസ്റ്റൻസ് എന്നുള്ളിടത്ത് നമ്മൾ എന്ത് കൊടുക്കണം? എക്സ് കൊടുക്കണം. ഓക്കെ, ഇവിടെ യു 0 ആണ്. മുഹമ്മദ് അതിൽ വരുന്നുള്ളൂ, വെറുതെ അല്ല വിളിച്ചു കിട്ടാത്ത. അപ്പം എക്സ് ഡിസ്റ്റൻസ് ഇറ്റ് മൂവ്ഡ് ഡൗൺവേർഡ്സ്. സോ വാട്ട് ഈസ് ഇറ്റ്സ് velocity, final velocity when it is at B? V square equal to U square plus 2AS or 2GS. S is X here. Okay, that value you have to substitute. So I will show you the substitution. At B, kinetic energy of the body equal to half m v1 square, and that is what we have calculated here, final velocity. V square minus U square equal to 2AS. We just write V1 because at the topmost point velocity, initial velocity is 0, and when it moved through a distance x, velocity is V1. When it moved through a distance h, we got the velocity 2GH, V square equal to 2GH, and here we take another velocity V1 square minus 0 equal to 2gx. X distance it moved downwards. That is the distance moved downwards, x. And g is the acceleration due to gravity. So what is v1 square? Equal to 2gx. That is v1 square. And that value we have to substitute. Half m v square. Kinetic energy equal to half m v1 square. So half into m into v1 square is 2gx. 2 and 2 get cancelled, we get mgx. Kinetic energy equal to mgx. What is potential energy? Mg into h minus x. So what is total energy, which is mechanical energy? Total energy means mechanical energy. It is the sum of kinetic energy and potential energy. So you have to add both these energies, mgx plus mgh minus mgx. So mgx and minus mgx get cancelled, and we get mgh itself. So what we have proved here, at A, B, and C, at all positions during the free fall of a body, the total energy is conserved. Total energy remains constant. But one condition is there: the forces involved are conservative forces. In such a field only, conservative field or conservative force, only the energy will be conserved, mechanical energy is conserved. So we have proved total energy is conserved during the free fall of a body. It is an important question, 2-mark question. Show that mechanical energy is conserved during the free fall of a body. And we have plotted a graph also. A means topmost point, it is stationary at A. So which energy it is having at A? Which energy it is having? Krishna Prabha? At a topmost point, when it is held at A, which energy is maximum? Krishna Prabha. Agda. At highest point, which energy it is having? Body. It is held at A. Krishna Prabha is there? Yes. At A, when it is held at A, at a height h above the ground level, which energy it is having maximum?
Potential energy.
What is the equation? Equation for potential energy?
Half kx square.
Half kx. That is for elastic potential energy. This is gravitational potential energy. What is the expression? Somebody told.
Mg.
Mgh. Why? Mr. Prabha? This is gravitational potential energy. Other one is spring. will stretch or compress the spring and the energy possessed in the spring. That is elastic potential. Half kx square is elastic potential energy and mgh is gravitational potential energy. Okay.
Okay, ma'am.
Okay. So at the topmost point A, it will have maximum potential energy. Then, and it is falling downwards, and when it reaches C, height is decreasing. Height decreasing, so potential energy decreases and becomes zero. At C, just before it hit the ground, potential energy is zero. So this is the graph for that. Graph for energy and position. At A, which energy? Potential energy maximum. And at C, which energy? Potential energy zero. This is the graph for potential energy during the free fall of a body. Similarly, kinetic energy of the graph. Where is kinetic energy maxima? Just before it hit the ground or when it is held at A. Nana? Tell. Nana? 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 No answer. Adilakshmi is there? Adilakshmi? Adilakshmi? Simple question I asked, but no answer. Neeraj, tell Neeraj. Neeraj. Neeraj also not answer. Abhinav is there, Abhinav? Abhinav.
Teacher?
Abhinav ആണോ?
Yes, teacher.
When the body is held at A, what is the kinetic energy?
Zero.
Correct. Just before it hit the ground, kinetic energy we have calculated. What is it?
mgh.
Very good. So, kinetic energy is maximum just before it hit the ground. You see, at C, kinetic energy is maximum. Blue graph, that line drawn, that is representing the kinetic energy. It is maximum at C, just before it hit the ground, kinetic energy is maximum. But initial point, it is held at A, so kinetic energy is zero. Then increases, just before it hits the ground, kinetic energy is maximum value. We can see that during the free fall of a body, when we add both the energies, kinetic energy, potential energy, here they are equal. See center point. Center point between A and C, at the center, both the energies are equal, kinetic and potential energy. And other positions you see just near to A, which energy is maximum, potential energy is maximum. At that time, kinetic energy is minimum. So like that, during the free fall of a body, we can see sum of the energy, potential plus kinetic, that remains constant. So that is what we have proved. And what is the question for that? Show that mechanical energy is conserved during the free fall of a body. Graph also have to study. The next is various forms of energy. That we know different forms of energy, heat energy, chemical energy, electrical energy, nuclear energy. Different forms of energy are there. And in a textbook, that textbook page 126, it is explained. So that one you can study from text. No need to copy it, you study from text. Just important points we can discuss. Heat. Heat is a form of energy. We have seen that the frictional force is not a conservative force. However, work is associated with the force of friction. A block of mass m sliding on a rough horizontal surface with a speed v0 comes to a halt over a distance x0. The work done by the force of kinetic friction. So the only You just know the different forms of energy. Heat energy, no need to go to detail. Heat is a form of energy. Another one, chemical energy. Chemical energy, you can see due to the chemical reaction. A matchstick ignites into a bright flame when stuck against a specially prepared chemical surface. We know that. So that is chemical energy. The lighted matchstick, when applied to a firecracker, result in a spectacular display of sound and light. That is also chemical energy. So just to know that what is the heat energy, what is chemical energy, what is electrical energy, what is electrical energy. The flow of electric current causes bulbs to glow, fans to rotate, and bells to ring. So that is due to electrical energy. Okay. The next, this is important. Equivalence of mass and energy. What is mass energy equivalence? Have you heard of that? Einstein's mass energy equivalence. Equivalence. Mass and energy are equated with a formula. E is energy, M is the mass, and C is the velocity of light. Very important principle. Mass energy. Albert Einstein showed that mass and energy are equivalent and are related by the relation E equal to mc square. Where?
Teacher, when
Yes.
it transfers from one medium to another.
When?
Teacher, when it transfer from one medium to another, that
Uh.
equation.
Not this, not the equation. See, in
ടീച്ചർ
the
ലാസ്റ്റ് ഇയർ പഠിക്കാനുണ്ടായിരുന്നില്ലേ ഇത്?
ഇതുണ്ടായിരുന്നോ മാസ് എനർജി ഇക്വാലൻസ് ഉണ്ടായിരുന്നു, എനർജി കൺസർവേഷൻ ഉണ്ടാവും. ഇത് പഠിച്ചിട്ടുണ്ടോ? ഈക്വൽ ടു എം സി സ്ക്വയർ.
From light to a medium.
അത് റിഫ്രാക്ഷൻ അല്ലേ? വെൻ ലൈറ്റ് പാസസ് ഫ്രം വൺ മീഡിയം, അതല്ലേ? അല്ലാണ്ട് ഇത് പഠിച്ചിട്ടുണ്ടോ?
ഇല്ല ഇല്ല.
ഇല്ല. ഇത് പഠിച്ചിട്ടാണ് വഴിയില്ല. കുട്ടികൾ പറയുന്നത് കേട്ടിട്ടില്ല, ഇത് പഠിച്ചു. അപ്പൊ ഇതെന്ന് പറഞ്ഞാൽ ഐ വിൽ ടെൽ യു ഡ്യൂറിങ് fission reaction, during fusion reaction and all, energy is released. For example, I'll tell you, two hydrogen fuses to form helium. Two hydrogen atoms fuses to form helium, and you find the mass of hydrogen. So one side, two hydrogen atoms, and when they combine to form what? Helium. So hydrogen plus hydrogen, that is reactants, and helium is the product. So you just find the mass of hydrogen atom. Two hydrogen atoms are there. You just find its mass. So okay, we got the mass of two hydrogen atoms. Then after the reaction, that means after the composition, when helium is formed, you find the mass of helium. The product mass also you find, and you can see there is some decrease in mass in product. Product mass is going to be less than the sum of the reactants mass. Product mass is found to be less. Why? What happened to that mass? We know mass is conserved. What happened to that mass? See, during that reaction, when hydrogen is fused to form helium, you see that a decrease in mass is converted into energy. A large amount of energy is released during that process. That is actually fusion reaction. So large amount is energy is released during that reaction. Where it got that much energy? Fusion actually taking place in hydrogen bomb. Hydrogen bomb fusion reaction is taking place. A vast amount of energy is released which can destroy even cities, like that. So here, from where does this mass come? That mass is the decrease in mass found in the product. Decrease in mass found in the product, that is converted into energy. Understand? Which formula? mc square. So decrease in mass may be very, very small. For example, 1 IMU. 1 IMU will not be there. Say small mass, it will be less than 1 IMU. It will be there. But when it is multiplied with the square of the velocity of light, what is velocity of light equation? 3 into 10 raised to 8 meter per second. So when we square it, what we get? 9 into 10 raised to 16. See, that much energy. From 1 IMU, we are getting this much energy. Mass is converted, mass we have written. So, like that, during the fission also same thing happens. So fusion I explain, fission I will explain later. Nuclear energy I will explain that. So here we have seen two hydrogen atoms combined to form helium, and when helium is formed, its mass is found to be less than the mass of the hydrogen atoms. And what is happening to that decrease in mass? The decrease in mass is converted into energy. Which formula? Einstein's mass energy equivalence. Energy E equal to mc square. So small mass, even though the decrease in mass is very small, when it is multiplied with the square of velocity of light, that energy becomes very huge amount of energy is released. So, that is mass energy equivalent. Mass can be converted into energy. Similarly, energy can be converted into mass also. Understand? So that is a mass energy equivalent. This one you have to study very well. Okay, very important. Yes, this is the energy associated with the staggering amount of energy associated with the mere kilogram of matter. This kilogram of matter. Mass is converted into kilogram into c square. So 1 kilogram of matter, when it is converted into energy, this much energy we will get. 9 Newton raised to 60 joules. Next, nuclear. So you study this context. I have written in notes. Nuclear energy means what? Anyone? Any idea? I think you studied about nuclear energy. Midun, what is nuclear energy? Midun, what is nuclear energy? Any idea? Midun? No answer? Gaudam is there? Gaudam? 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 എല്ലാവരും മയക്കും പ്രശ്നം മനു then വേറെ ആരെ വിളിക്കാം ശ്രീരാഗ് 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 is there? No answer.
The turbine.
What is nuclear energy? Maharuni Satel. From the name itself, we can tell something. Nuclear energy. From where it comes? Nuclear. From the?
From the discharge of nuclear reaction.
From the nucleus. Nuclear. Okay. Nuclear energy is released from the nucleus. Nucleus consists of what all things? Nucleus. Anyone? Nucleus. In an atom, nucleus is there at the center, and its nucleus consists of what all things? Protons. And proton and electron. Proton and neutron. Nucleus consists of proton and neutron. Where is electron?
Electron is revolving.
Revolving around the nucleus. Okay. So the energy released from the nucleus, that is nuclear energy. Fission and fusion are nuclear energy. The energy released during fission and fusion. So please mute your mic, children. Mute your mic. Mute your mic. Okay. Okay, this fission you can see. A heavy nucleus like uranium is split by a neutron into lighter nucleus. Have you studied about fission? Anybody? Last year? Nuclear reactor and all. Have you studied about that? Yes. In fission, a heavy nucleus like uranium is the fuel in the fission reaction. Uranium element 92 is the atomic number, 235 is the mass number. It is split by neutron into lighter nucleus. This is a heavy nucleus. When it is hit by neutron, split into lighter nuclei, two lighter nuclei, barium, krypton. Such lighter nuclei are formed. And as I have told you, when these lighter nuclei are formed, that is the product. Uranium is the reactant, and the products are barium, krypton are the product, lighter nuclei. And neutrons also are there. Okay, so in that reaction, the product mass, when you find, there is a decrease in mass than the reactant mass. Or product mass is going to be less. So this mass, where has it gone? So that mass, decrease in mass, that is converted into energy. So in fission reaction also, the same thing happens. Some mass is found to be less in the products, and that decrease in mass is converted into energy. So that decrease in mass, delta m, it is denoted with the letter delta m, decrease in mass, difference in mass. So you can see once again, final mass is less than the initial mass, and the mass difference translates into energy, which can be tapped to provide electrical energy, as in power plant. Power plant, that energy is used. Fission reaction take place, and that energy is used to boil water, and when the steam comes, it can, at a very high pressure, the steam can turn the turbine, and we can generate electricity. That is happening in nuclear power plant. So I'll explain. First, the fission reaction is taking place. What is fission? Heavy nucleus of uranium split into lighter nuclei by hitting with a slow moving neutron. So when a neutron hit on a heavy nucleus of uranium, split into two lighter nuclei like barium, krypton, etc. And the product mass is found to be less than the reactant mass, and that mass is converted into energy according to which formula? E equal to mc square, Einstein's mass energy equivalence. So mass is converted into energy. So in fission reaction, that energy we are getting, heat energy, vast amount of heat energy is produced, and that heat is utilized to boil water, and water boils, what comes? Steam, and when steam is kept at very high pressure, it can do work, and it can turn the turbine, and we can generate electricity. That is happening in nuclear power plants. Controlled fission reaction is taking place. So that is about nuclear energy. Fission and fusion are due to this nuclear energy released from the nucleus of the atom. Nucleus, even though very, very small, even we cannot see with our eye, we cannot see nucleus, but it is having a vast amount of energy. And fission and fusion. Fusion is taking place in sun. Sun, we are getting a lot of energy from sun. Earth, all other planets are getting energy from sun. It is due to fusion. What fusion is taking place? Hydrogen fuses to form helium. The large amount of energy is released. Fusion reaction. Fission, where is it taking place? Nuclear reactor. Controlled fission reaction is taking place. So I think you have understood. If you have doubt, you can. Next. So different forms of energy you study from. Then principle of conservation of energy. Everybody knows that. What is principle of conservation of energy? I think no need to discuss about that. What is principle of conservation of energy? Sagar, can you tell what is principle of conservation of energy? Sagar. Meghana KP. Meghana.
Yes, ma'am.
What is principle of conservation of energy?
Energy can neither be
Ah.
created
Ah.
nor destroyed, can only be transferred from one to another.
Very good. That is conservation of energy. Principle that is written here. So that is what I told. Everybody knows that energy can neither be created nor be destroyed. It can be transformed from one form to another. That's the total energy of an isolated system. We have to underline that word, isolated system. Isolated system means no external force act on the system. So the total energy of an isolated system does not change. So you underline that word, isolated system. And then statement you can study from text. Okay, the total energy of an isolated system does not change as long as one accounts for all the forms of energy. So one form of energy is converted into other form. So when you find the sum of all forms of energy, that will be constant. That is conservation of energy. And power we have discussed before. Power is rate at which work is done. Average power is dW by dt. dW is the work done. dt is the time taken for that work. So work done by time, that will give power. Average power is work by time. And instantaneous power also we have calculated. dW by dt, that is equal to dW. W is F dot R. F dot R. F dot R. So that is F dot R. dW equal to F dot dr. Therefore, we substitute for W. dW is substituted as F dot dr. So F dot dr by dt we are getting, and dr by dt is velocity. Therefore, F dot V, power, instantaneous power. What is the formula? Vector F dot F vector V dot product of force and displacement. And the units of power also we have studied. 1 horsepower is 46 watts. SI unit of power is watt. 1 watt is also equal to 1 joule by 1 second, joule per second. And 1 kilowatt hour conversion. 1 kilowatt hour means what? 1 kilowatt means 1000 watt. Into 1000 watt into 1 hour means 3600 seconds. So 1 kilowatt 10 raised to 3 watt into 3600 seconds. Kilowatt hour. So we have converted into SI system. Kilowatt is changed into watt, SI system. And hour is changed into second, because that is the SI unit of time, second. So kilowatt is changed into watt, time, hour is changed into seconds. So you get this 3.6 when you multiply this. 3.6 into 10 raised to 6 joules. So 1 kilowatt hour. Kilowatt hour is the unit of energy. But don't think when you see kilowatt here, don't think it is the unit of power. This is kilowatt into hour is there. Power into time is there. No? So that here kilowatt hour is the unit of energy. Kilowatt hour, how will you write? K, small k. Watt, W, H, small letter. Kilowatt hour. Kilowatt hour. 1 kilowatt hour is 3.6 into 10